Venkatesh Seetharam is an architect and developer with Hortonworks. Venkatesh, welcome to Software Engineering Daily.
Thanks, Jeff, for having me on board.
You have been working on Hadoop since 2006. What was it like to work on Hadoop back then?
That's an interesting question. I was at Thomson Learning, now Cengage Learning in 2006. I was a distributed search architect, and we were trying to build a distributed search engine, and we had billions of documents, and encoding was a challenge. So we saw this shiny new toy called Hadoop, and I started trying it out towards the end of 2006. Hadoop was probably at 0.10 version, and it was pretty hard to use. A lot of things were not working, and I started very actively reaching out to the core developers on the Hadoop team, and befriended one guy, Devraj, and I got certain patches, and it was interesting because what took us days to encode, was done in my first version in 6 hours. That was very, very attractive for us, and started scaling out and working through the issues, and got to 0.12, which was much more stable by 2007. And we actually deployed it to pseudo production, where it was encoding billions of documents into Lucene indices.
And what have been the most dramatic improvements since 2006, 2007?
Oh, it's countless. I mean, Hadoop was not usable and not stable. There was no security. In 20, we added security at Yahoo. There was Kerberos support. Then there was a lot of improvement in stability of Hadoop with 20.20 version. We actually had about 11 or 12 release candidates for 20, which worked through various stability issues of drop tracker. And the most significant improvement that I see with Hadoop from in the 2007 to today is the Yarn data operating system. The resource manager was completely rewritten from Hadoop 1.0 to Hadoop 2.0 so that it can support different workflows. If you know Hadoop supports MapReduce workloads quite well, and that's the differentiator compared to other resource managers that exist in the industry today.
So you mentioned the Yarn. What is Yarn?
So Yarn essentially is what we call a data operating system. Yarn allows you to deploy a piece of software which can support multiple types of workloads. One of the classic workloads that come with Hadoop is, I would say is MapReduce. And you can, distribute your processing compute on, terabytes to petabytes of data across nodes. And that was one of the paradigms supported. Today, we have multiple, paradigms, programming paradigms, execution paradigms like Spark, Thais, Flink, Apache Flink, and each has its own pros and cons, right? I mean, it's end of the day, what suits your workload or your use case. And Yarn has made this possible where we had only one programming paradigm, which was MapReduce, to allowing us to actually scale out and process petabytes of data across, networked computers or nodes in matter of, few minutes to hours by allowing this open-ended programming paradigms to be developed on top of it. The other one important thing is MPI, right? And Spark kind of works really well with iterative algorithms, which was not in MapReduce.
Great, yeah. So I want to get into Spark eventually, and I also want to touch on Apache Flink, but let's get a little more context about you and where you work. What is Hortonworks?
Hortonworks was, we were looking at I was not there in 2006, but the Yahoo search team, YST, was looking to scale out the web crawling from 1,000 node cluster to something beyond that because the web map was very big, right? So there were a couple of guys, Eric Waldschweiler, who was the VP of the team who actually created Hadoop. He and Remy Stada, who was the CTO at Yahoo, hired Doug Cutting, who was actually working on Nutch, into Yahoo, and they started a new initiative called Hadoop within Yahoo, which was available as Nutch within the open source community. And in 2011, when Hadoop became kind of very disruptive, a lot of enterprises started adopting Hadoop, thanks to Cloudera, of course. In 2011, Yahoo spun Hortonworks off as a separate company to actually support Hadoop customers with a very unique, business proposition, which is complete 100% open source Apache Hadoop.
So are you saying, does Yahoo own Hortonworks?
They don't own. We are an independent company, but they invested in Hortonworks. So in that sense, they have some ownership. Yes.
Oh, okay. Interesting. What do you work on at Hortonworks?
So I've been, working on data management slash ETL for, the better part of my life at Yahoo and Hortonworks. So I started, a data management initiative, which started with, extract and eventually built, the transformations and, data quality and cleansing and DR capabilities within Yahoo, which was working at internet scale. It was, managing 300 terabytes of data over 3,000, data sets at Yahoo. Then, we saw that when we came to Hortonworks, we wanted to have an ETL tool that was bundled along with HTTP, which is open source. So I worked with Pentaho and Talent, and eventually got Talent bundled along with HTTP with Apache license, and then worked around data integration pieces. We had some pieces of Scoop, Flume, and Uzi, and got that as part of the HTTP Hortonworks Data Platform distribution. And after about a year and a half, once these settled, I went out and created Apache Falcon along with my friends at InMobi. These are the people that I worked at Yahoo, and they had some form and shape of Apache Falcon, which essentially is a data processing and data lifecycle management platform for Hadoop, and got it into Apache, incubated it in Apache, and made it part of Hortonworks data platform. For the past 7 months, I've been working on data governance solution, which is incubated in the form of Apache Atlas and shipped with Hortonworks Data Platform today.
Right, and so we'll go into that eventually.
Sure.
I'd like to shift to talking about a general challenge that I think exists in the big data world right now, which is the transition from mostly batch processing to architectures that have streaming and batch. How do you see this transition and the problems associated with it? How do you see that transition manifested in Hortonworks' customers?
That's a very interesting question. So everything starts out small and batch, right? And people start out with their research clusters until they prove some value. Once they prove the value, now they want to take what they had, which runs daily or even weekly, to starting with smaller intervals. This is a typical pattern that repeats in every enterprise customer that I see. You start out daily or weekly and then want to make it hourly. And, once you see a lot of value, you want to run that every minute and then start, near real-time streaming. And that transition is not very easy today, right? So because we have different solutions for batch and different solutions for streaming analytics. So we have, Apache Falcon, which is batch. You can fire up Uzi as well and roll your own data processing platform using Hive, Pig, and other components, or you use, Storm or other solutions for streaming.
And so this transitionary process, most customers are probably going to go with a managed big data platform in order to do this, or they'll already be on a managed big data platform. So there's like Hortonworks and Cloudera and
yes,
and then MapR and some other ones. So how does the approach? Maybe we could use this transition from batch to streaming to describe the differences between between these different managed big data platforms. Like if for these different managed big data platforms, how would the approach differ between, for example, Cloudera and Hortonworks if they had a customer, or if you had a customer that wanted to get streaming functionality to complement their batch functionality?
Well, that's a good question. So, I am not an expert in Cloudera, enterprise.
Sure, you don't have to speak to Cloudera. So, you could also just speak about Hortonworks.
Sure. But, largely, we have a solution in the form of Apache Falcon, which gives you a higher layer of abstraction to work with. We define the three entities, the trinity, the infrastructure, the data on that infrastructure, one or more infrastructure, and then you have processing, right? So you can express this in a higher layer language and farm out your processing. Cloudera has taken a much more API-driven approach with Kite SDK. So that's pretty interesting. But Hortonworks gives you these tools on top of Hadoop to work with, where it is not API driven, but work with different abstractions and declarative language. The thing that is most interesting to me is you would never get away with batch, because streaming is very good for getting the last 15 minutes, kind of aggregations and simple aggregations. You can't do over time aggregations where you have rolling windows and things like that. But if you want any complex, analytics, you would still need batch. So I think they go both side by side, and you aggregate results from both of them. So there is a new architecture that Nathan Mars from Twitter, called Trident, right? It basically marries both streaming and batch analytics, and has solution which kind of collates both of them and surfaces those results.
Could you describe that Trident solution?
So essentially, you basically run your batch for older data for 3 months, 1 month, or daily, and the last hour or whatever latency that you want, however capacity that you want, you keep computing the streaming results over an hour, because batch runs probably on the hour, and streaming gives you the last hour's data as well. So you combine this last day's run or up to an hour, and then the last 15 minutes or the last 30 minutes run, combine them and surface the results up. So you have the latest data in your analytics for you to, look at. Does that make sense?
Yeah, that makes sense. So there's been an explosion of these managed big data platforms like Hortonworks, Cloudera, Confluent, and many others. How have the expectations of your customers changed as there has been this growth of managed big data companies?
That's a very, good question, and a problem as well, right? I mean, there is a lot of tooling that's happening, and Hadoop is so raw and immature at this point in terms of adoption, that a lot of people are creating parallel solutions. There are differences in those solutions as well. I think given the next 3 to 5 years, there has to be consolidation. We already see a lot of consolidation now. Like Hortonworks acquired a security company, right? Secure, and we open sourced it called Ranger. Cloudera acquired Gazang, another security company. So there is some consolidation in security. I'm pretty sure there are a lot of new tools that are coming up. So Confluent is an interesting one, that they don't actually support Hadoop, but they have this messaging broker called Kafka, which works really well out of on top of Hadoop, and streaming analytics solutions on top of Hadoop. So that is one area that has not seen a lot of explosion. But if you look at streaming analytics itself, we have DataTorrent, which has a product called Apex. We have Storm, which Hortonworks and Cloudera supports. We have Spark streaming. We also have Samza from LinkedIn. I'm not sure if Confluent supports it or not, Samza, but they go, Kafka and Samza go together. So and there is also a lot of new companies like StreamSets. A few of my friends from Cloudera, started, and Informatica started StreamSets, which does, streaming analytics. So I'm seeing there is a lot of tools that are popping up, and I think eventually, once everything matures, there will be some consolidation.
That's interesting. I hadn't thought about that. I mean, it seems like the type of thing where, like, even if there was consolidation, there's no way that the consolidation would outpace the amount of new products that would develop in the area. And so
Yes.
so the way that I see it is like, this future, there's this really worrisome future of just like this explosion, like in the data center, there's this explosion of products that you really want to patch onto your big data architecture, like, Mesos, Docker, et cetera, et cetera, et cetera. And it's just like, oh my God, I have so many of these things and I'm not sure how to configure all of them. Am I going to be spending the entire day on the phone with different cloud service providers? Is that a potential future?
That's a wonderful question. So you nailed it. So it is true that there's confusion, but that's where, distribution companies like Hortonworks, Cloudera, and MapR, right? And, Pivotal and IBM come in. They take the best of breed technologies, right? certified against these platforms and say this is what a reference architecture looks like for certain use cases, right? Or these use cases. And these I call these distribution companies because they own the Hadoop distribution, but they also give you this certification process, and we work with partners to certify those products against the stack and give you a holistic view of what works better for certain use cases. So I think these companies are already consolidating many solutions. Not that there will be islands of solutions, but a big customer, enterprise customer, to reduce his risk should go through one of these distribution companies and take their expertise and land the tools that actually work. So if to give you an example, we have created this data governance solution called Apache Atlas. We actually have a governance ready certification that we work with multiple partners for different areas of use cases that they cover. And that means, if you have a certain use case and if that partner is already certified on this product, you can go ahead and buy them. So there is no confusion there. Does it make sense?
Yeah, that makes sense. I mean, one thing I'm curious about is, as we have, an increasing explosion of big data products, and we have more and more problems in the data center, more varietal problems, is there any chance that the number of solutions architects that we need will not keep up with the amount of problems that we have?
As more adoption grows and more people start to architect solutions, there will be best practices that will emerge out of these solutions, right? So as I said, people who are, you don't have to be bleeding edge to use Hadoop now. If you're leading edge, you can use Hadoop, right? There are laggards as well. So the problem is with laggards. If you have leading edge today, there are solutions in Hadoop. You can talk to the community, which is very open. And there are a lot of use cases and best practices already, available. There is even a book called, at O'Reilly called Hadoop Best Practices. So I think more and more vertical specific best practices will evolve over time. And we already have an initiative where we are creating reference architectures for each vertical. We have Mark, which leads our vertical centric solutions, and he's hiring GMs from different verticals for healthcare, retail, insurance and things like that. So I think it's over time, I expect reference architectures and best practices to evolve so that you don't need to scale technology with, solution architects. Does that make sense?
Interesting. Yeah, no, that makes a lot of sense. It's sort of like, maybe today, we don't hire, Scrum masters or agile coaches as much anymore because that stuff has become such institutional knowledge. You can just kind of look it up on the internet if you really don't know it. So let's talk a bit about your open source projects, and then we can maybe use that to segue into a discussion of Spark, because I think Spark or streaming in general, Storm is an important topic to discuss. But to touch on your open source projects, you've worked on a project called Falcon, and Apache Falcon is a data lifecycle management framework. What is the data lifecycle?
That's a very good question. So typically, right, you get your data into Hadoop. You ingest data or extract data from external systems into Hadoop. Hadoop is not a transactional system and it's not the source of truth. So you have various ways of collecting your data from your web servers, from your transactional systems, from legacy systems, what have you, and the data lands in Hadoop, right? Once the data lands in Hadoop, there are certain compliance policies, also capacity planning. You can't have data keep growing forever and keep the old data forever. So, and you cannot rely on users to adhere to any compliance policies. One of the policies is, very simple policy is a disposition rule. This data, which has, PII information, cannot live on a Hadoop cluster for more than 90 days. That means it has to be anonymized and kept. The second thing is the raw data cannot live there for more than 90 days, right? That's an example. The anonymized data should live for compliance reasons for 7 years, right? So that means, you have to have a policy that says, I need to dispose this data after 3 months. Somebody has to do it. Today, the tools that come with Hadoop, right? Not everything works the way it should. even in the data warehouse world, right? 50% of them use tooling like Informatica, Data Stage, whatever else, Talent, Pentaho. In the Hadoop world, people everything roll in their own back room, right? They write scripts to do this. So what we saw was we took a bunch of use cases, reusable use cases out of the box, and packaged them with this tool called Apache Falcon. The first thing is the disposition rule. The second one is if you're processing your data, you want to take your data from production for disaster recovery and put it in your copy it into your BCP cluster, right, if you will. Also, Hadoop has a very different usage. There are different classes of users. One is your production user. The other one is research users. You may have dev users. You may want to copy this data over to different class of Hadoop clusters, which are partitioned physically as separate clusters. So you want replication of this data, right, to achieve. One is the disaster recovery or BCP. The other is different class of users. And you want these replication policies to be dynamic. As soon as data becomes available, you want to copy this data without a lag, right, with some SLA. So this essentially is what we call lifecycle, the copying of this data for DR,
right.
Evicting this data. The other thing that Falcon provides, which is very interesting, is this pipelines, right? Data pipelines. You can express, a process in Falcon and chain them together based on these data dependencies between them. So you can have a multiple staged processing lifecycle that goes from, let's say ingest to doing some transformations, series of transformations to the data and generating an output, right, which will be consumed by reporting. So you export the data into your reporting, software or database and start, churning reports or dashboards, what have you.
Right, and so there's a Falcon example that I'll include in the show notes where you talk about the failover that it provides, and you've got a 4-stage data pipeline, and the 4 stages are staged data, cleansed data, conformed data, and presented data. The presented data is the end result that somebody would consume in Tableau or some other analytics platform. And as I understand, the example that you're trying to display for the Falcon is that Falcon allows you to define points along that data pipeline where you want replication. So in your example, you've got this 4-stage data pipeline, and you decide to replicate at the first stage and at the last stage. Is that correct?
Yes. So, and you can have different eviction policies for each of these staged intermediate data as well. You can keep the intermediate data for some time, or you can actually delete the intermediate data right after the processing is done.
Okay, cool. That seems super useful. So I want to jump on to talking about Apache Knox Gateway, which is another platform that you've worked on. So Apache Knox Gateway is a REST API gateway for interacting with Hadoop clusters. What is a REST API gateway?
That's a good question. So Knox was built to work around the security issues with Hadoop. Hadoop security is based on Kerberos. That means, if a user has to get a Kerberos token from the KDC before they actually use a service of Hadoop, that means users have to have access to the edge nodes in the Hadoop cluster. So there are some front nodes. Typically, a Hadoop cluster does not have access to any users, right? Because it's all, protected. So you can't even get to an IP address of your cluster. So to work around the secure Kerberos issues, what we do is we give you a set of nodes that you can log in, get a Kerberos token, and then interact with the services. This makes it very hard for applications to interact with Hadoop, right? Because they can't log into a head node. So Knox was created as a simple gateway or a proxy to actually proxy your request from your external applications and use the RESTful API across the components in the Hadoop stack. So Knox is a very simple, it's like a single sign-on. You actually interact with Knox. It has plugins to interact with your LDAP, AD, what have you, authentication mechanism. And once you authenticate with Knox, again, RESTful API, it's a nice way to actually interact with Knox so that Knox actually redirects your request saying, this guy is authorized. and allow access to this person, this user or application.
So according to the documentation for Knox Gateway, it says, quote, while there are a number of benefits for unsecured Hadoop clusters, the Knox Gateway also complements the Kerberos secured cluster quite nicely. What are the trade-offs between a secured and an unsecured Hadoop cluster?
In unsecured cluster, anybody can access anyone's data, right? You can basically say you are, let's say, Jeff is the CEO of a company, and he has access to pretty much all the privileged data.
I like this example.
Venkatesh is just an employee in the R&D, and he can go and dig up financial documents that he does not have access to by pretending he's Jeff and get access to that data in an unsecured cluster, because we believe you are telling the truth in an unsecured cluster. So if you want true security, where you don't want to give access to anyone else who is acting as someone else, to prevent such accesses, you have to enable Kerberos, and you get true security there to file system, to every other component. So I can't, step over someone else's stores. I can't delete someone else's data. I can't look at someone else's data. I can't run queries on data that I don't have access to.
Sure. Okay, cool. So, now we're going to talk about Apache Atlas. I know we're talking about a lot of different technologies, but these will all be in the show notes. If you didn't understand the discussion just now about Knox Gateway, we can, you can look in the show notes. So, but you've also contributed, and I think you're working on right now, Apache Atlas, which is a data governance and metadata platform for Hadoop. What was the motivation for creating Apache Atlas, and what is Apache Atlas?
So we, after interacting with many customers, we realized data governance is a very important service that our customers expected out of Hadoop. And what does governance mean? Governance can mean many different things, but there is transparency, auditability, right? Security, and traceability. These are the four aspects of governance. And we quickly realized, without governance, it's very hard for users to put their, financial data and take things to production. So we started thinking about a solution here. And since we are not experts in this, we actually were working with a consortium. We created a consortium called Data Governance Consortia, and we have retail representation with Target. We have healthcare representation with Aetna. We have big financial representation from JPMC. We have oil and gas, Schlumberger. We have a bunch of 7 or 8 co-development partners who are serving as subject matter experts for us to understand what governance is. So basically what we then came to a solution was we clearly need a core metadata service in the Hadoop ecosystem and marry the bunch of components that we have already built together, kind of put 3 or 4 components in a box to achieve a governance solution. So we realized the gap was the metadata, and Atlas was born as the core metadata engine for Hadoop, which basically exposes a type system, which allows you to, or enables you to express your meta models and in the type system, and have correlation between them, and also express a business glossary or taxonomy which is specific to each vertical, right? And that was how Atlas was born. So there are, we are saying Atlas is a core metadata store, but how do we achieve governance? So for security related stuff, so a very simple example is, attribute based access control. So all the security related policies which are stored in Atlas are realized by another product called Ranger, which is a security product. And all the lifecycle features, like, if you want to govern this data, you need to dispose this data in 90 days, right? That lifecycle management is realized by Falcon. So Atlas acts as a holistic global metadata store with rationalization of different policies by different engines like Falcon and Ranger.
How do people? I think one of the big differences between having a batch or an all MapReduce framework versus having a framework that is powered by Spark or Storm is that instead of having a system where each of your big data pipelines consists of having a map job, a shuffle job, and a reduce job, where you've got these three things. With Storm or Spark, you can create this topology where there's a much more generalized sense of the different phases in a pipeline. Would you say that that's accurate?
Sure. I mean, as I was saying, right? I mean, you cannot eliminate either of them, right? They both are necessary evil.
Right. Okay. So interesting. Let's see. So I guess what I'm trying to get at is what in the transition from batch to streaming, what does the software re-architecture process look like?
So that's a very good question. So I think the tooling today does not give you a way to run your batch analytics on streaming, which is what I think is, Spark streaming is all about. You could take a logical plan and run it in either batch or streaming mode in Spark. But traditionally, if you're using, Storm and, other things like MapReduce or even Thais within the ecosystem today in your products, you won't be able to take your code and run it as both batch as well as streaming and then collate the results, as I was talking about earlier. So there are two different solutions and you have to code up in two different ways.
Interesting. And what are the if you have any ideas on this, but I'd love to get a good answer. But if you don't, that's fine too. But what are the big differences between Storm and Spark?
Storm essentially is a type of streaming solution for Hadoop. Spark is an execution layer. So Spark streaming and Storm are competing technologies. Okay. But Spark itself is an execution layer, Spark, which is more akin to, MapReduce, a better MapReduce, Thais. You can express any processing in Spark execution engine. Does it make sense?
It does.
Spark is a general purpose execution engine versus Storm is an execution engine for streaming analytics.
So, okay, if Spark is a general purpose execution engine, what is Hadoop? I thought Hadoop was also a general purpose execution engine.
Hadoop provides a execution engine on top of Yarn, which was MapReduce, and now it is Thais. Spark is yet another execution engine. So think of Hadoop as a fabric, a data fabric, okay, where you have your data and a way to partition your compute, okay? Now, the execution engine is the actual runtime, which actually takes the data and works on the data and takes the compute that you've written, the code that you've written, and applies that on the data. The infrastructure is Hadoop, but the actual execution runtime is provided by MapReduce, by Thais, Spark, and Flink. So these are the execution runtimes which snap in on top of Hadoop, which are pluggable, right? Now, for Spark to run, it needs first to understand where the data is, which is provided by HDFS, right? Where are the locations? Even before it does that, it needs a set of nodes to be assigned to execute its task. All that is done by Hadoop, which is Yarn here, right? The resource manager. And if you want guaranteed capacity, you need to actually get a cluster of nodes for Spark to submit its jobs. The cluster of nodes is given by Hadoop.
So would you say that in the past, Hadoop was, HDFS and MapReduce, and now Hadoop is HDFS and X, where X is
HDFS and Yarn. HDFS and Yarn.
Okay.
Yes. And the snapping of execution frameworks is enabled by Yarn, which was not. The only execution framework that was supported in Hadoop 1.x was MapReduce. Right. Now with Yarn, you have this new possibility. It opens up a whole lot of possibilities for multiple execution frameworks like Spark, Flink, Thais, right? And roll your own.
So tell me about Apache Flink, because this is something that I've heard about in the reporting for these shows, but I don't know anything about Apache Flink.
So Flink is a very interesting new technology and open source as well. So Spark gives you a view. Spark has very nice abstractions, right? Programming, runtimes are all about abstractions. So Thais has a certain, level of abstractions which was modeled after Microsoft Dryad, and Spark kind of gives you a different, sets of abstractions like RDD. RDD, is the fundamental unit of looking at, processing data within Spark ecosystem. Flink gives you a different set of abstractions, but Spark is primarily batch, and streaming is essentially very small batches, in time, right? 1 minute window or 2 minute window is what is streaming. Flink kind of inverts it, and it starts with streaming. Everything is streaming, and batch is essentially longer windows of time, right? So it depends on what paradigm that you like to work with, and what is mature out there, right? And what suits your use case. So there is no silver bullet here. You know what I mean?
Yeah.
So there are we have seen as a company that we support Thais, and we support Spark as well. Flink is kind of new kid in the block. We are looking at it. I don't know what the formal answer for our support for Flink at this point is.
So when you have, let's talk a bit about that, because it seems like this open source, the business model where you have like people that are working on some open source software, and then you have other people that are providing the open source software as a service. It's interesting because if the open source community comes up with a new idea, Hortonworks, or whether you're Hortonworks or Cloudera or something else, you kind of have to implement it. So it's this interesting business proposition where you can have these black swans that develop out of the community, and then as Hortonworks, you kind of have to support it. So what is the process for, do you have a standardized process, like a standardized review process where you look at a new open source technology and say, okay, we're going to decide to support it, or we're going to decide not to support it?
Yeah, it works multiple ways, right? One is if the customers have already adopted certain technology because it's cool, and then it stabilizes, and it also makes sense from our perspective, right? We have we have architecture council, we have management who basically makes these, keeps looking out for cool technologies, or creating our own. Like Falcon was created in-house, Atlas was created in-house, right? Everything pretty much was created. We bought a solution for security, and Spark is something that we adopted from the open source. Storm is something we adopted from open source because a lot of customers started asking us, we need a streaming solution, and we didn't have one. We said, okay, let's adopt Spark. Storm, and dedicate resources to it. And we have a few committers in Storm now, 3 or 4. Kafka was the same thing. Kafka was something that we saw there is demand for it among our customers, and we either support the open source movement and make it certified against part of HTTP. We have added security for Kafka and Storm, right? Kerberos. We have Ambari, which is the installer for Hadoop, which is again open source, and Ambari installs all these different components. So it's all about what momentum does the software has, what is the demand from our customers, and the viability of the product itself in terms of quality, supportability, yada yada yada.
Yeah, so I want to talk about something a little more general. How have the fundamental problems in distributed systems changed since you started working in the space?
Wow, it's pretty interesting. It's to answer it short, I started with Corba, right, back in 2000 or even earlier at NetDynamics. It was a startup here which Sun acquired us in 1998, 1999. There we used to use Corba for distribution of services. It was very hard to debug, right? There was pretty interesting technology, but very, very hard to debug. It was a nightmare. And then at Thomson Learning, there was Michi Henning, who actually, was one of the primary authors of Corba. Steve Winoski and Michi Henning. Michi Henning got out, he got frustrated and created, with few other cool guys create something called ICE, Internet Communications Engine, which was a simplified CORBA, and we used that to distribute our indices, for distributed search at Thomson Learning. And Hadoop kind of reinvented its own RPC. Hadoop RPC is extremely optimized for very large scale clusters. We had 4,000, 6,000 node clusters at Yahoo. We had 40,000 nodes in the cluster. This is 2011 numbers, and we had 26 clusters. Hadoop has evolved a lot. We also learned a lot from creating a lot of RPC mechanisms. We use protocol buffers now that came out of Google. There was Thrift again, which is partly used in which is used in Hive, but most of the Hadoop core uses protocol buffers today. So it's been an interesting evolution that there has been a lot of simplification. In between, there was EJBs as well, right? I mean, that was trying to fix what CORBA did, but it was not successful. So I think there has been a huge evolution in distributed systems, and it never gets easy. But at least there are a lot of frameworks, a lot of reference implementations, so that we don't have to create from scratch.
Do you consider distributed systems more of a philosophy or a science?
It's a science. I mean, there are a lot of things that could go wrong, and working through them is the challenge. That's why there are a lot of paradigms today, right? There is CAP theorem. There is people who don't believe in it. So it is a science.
Are you a believer or a non-believer?
Of distributed systems?
Of CAP theorem.
I am a believer.
What are you what level of orthodoxy are you?
I mean, every engineer is very religious about something. Otherwise, I don't consider him an engineer. We all are religious about many things. So we have our own, nuances to work with. But again, if you have the humility that without a team you can't create something cool.
Well, but everybody also has their own specific and nuanced beliefs, though. Also, so I'm curious, what are your nuanced beliefs of the CAP theorem? And maybe we should quickly define what the CAP theorem is, and maybe
interesting. That's going to take a longer time, but
I know we're running low on time, but maybe you could just discuss.
Yeah, the thing that I want to kind of impress upon is the solutions that we have right today, because there are many execution frameworks, different abstractions. I mean, even for key value pair, we have the Google level DB. We have the key value store, distributed key value store in HBase. There are many key value stores. There is Cassandra, right, which is completely different from HBase, which offers different semantics, right? We also have HDFS, which is just streaming data. So there are different solutions for different use cases. Again, there is no one size fits all. There is no silver bullet in science or in computer science, even among customers, right? I mean, each one has certain crazy requirements that requires you to make certain trade-off, and engineering is all about trade-off. So if you look at a solution, if you understand what trade-offs have they made to us arrive at this decision, then you clearly understand why and should that be used or not, because that trade-off, does that trade-off work for your domain, is the fundamental question that you need to ask, and then pick a technology, right? So I'm not saying we are religious about solutions, but religious about what trade-offs to make based on our experience and based on the domain that you're working with, because HBase is not a good key value store for all use cases. Cassandra is winning as well in certain customers, because that's what is their use case and not the kind of use case that HBase supports. You know what I mean? So we have strongly consistent systems because it's easier as well when you're working with scale. HDFS is so simple because it is very consistent, right? Until all the three replicas are written, it won't return to the client. That means either you are successful or you fail. There is no split brain problem, right? Definitely. Now Cassandra is eventually consistent. There are a lot of things that could go wrong. So if you're interested in distributed systems, I would offer you to take a look at Kyle Kingsbury. He has a series of blog posts explaining how things work. It's Aphyr, APHYR, I think is his website, and they're very interesting things. He has written a tool as well to test distributed systems. And, a lot of things fail. I mean, Elasticsearch, MongoDB, they're not, consistent at all. So if you want to understand CAP theorem, that's a good place to start with, in my opinion.
Interesting. Okay. Well, so just to begin to close off, I guess I'd like to ask as a final question, what are the most interesting problems in distributed systems right now, and what are the most interesting solutions?
So I think, how to make distributed systems dead simple is what Hadoop has tried. And I think we have kind of evolved over a lot of crappy things, which was, of course, very useful as well, because there was nothing else, in its place. And from MapReduce to where we are with Spark and, Flink and These is, I think, a huge evolution, because, with few lines of code with these frameworks, you can write very interesting, things, and write data science applications on top of Hadoop with very little effort, right? And Spark integrating R, ML, Graph ML, it makes it very, very interesting to actually chain a class of problems and then executing them and understanding and deriving insights of data is what I think is very promising.
Great. Well, Venkatesh Seetharam, thank you so much for coming on Software Engineering Daily. It's been a real pleasure talking to you.